So, Mark, we're on to problem 3 and solution 3. You're earning your money so far, which is great. So we're going to talk about integrations and dependencies now, and we kind of touched on it in the last point even. Quite often, it's not just 10, 15, 20. It can be 100 or hundreds of integrations and dependencies. Obviously, that creates a huge amount of complications. What's your view on the best way around this and how we can actually set the best platform up to continue being innovation-led and make sure that pace of play is at least as fast as our competitors?
Yeah, sure. I think this is a big topic for me. We've worked in integration for many, many years. I'll be giving away my age if I said when I wrote my first integration between 2 systems. But I think that it is really, really important we get this right. Migrating a legacy system to a new technology is only half the story. That system, if it's an enterprise system, needs to ensure that all of the integration touch points to downstream systems that you're dependent on and that you're providing data for need to work seamlessly within the new system. And I'd say it's one of the biggest headaches for the large programs, that they can be quite clear on what they're in control of and what they can transform their application to, but making sure all the dependent systems still work and making sure that everything you're dependent on is still plugged in is probably one of the biggest challenges. And it's a challenge that there's been many solutions over the years. And actually, if I do a bit of history here, when people started looking at enterprise IT systems, the proliferation of integrations just grew, really quickly. I don't even just mean the systems that you're trying to integrate together, your finance system with your ERP system, with your CRM system, with your customer-facing portal. It's the touch points within those. Within each of these, there might be 10, 100 different touch points where data's flowing between these systems. So you end up with quite a large problem. And what vendors did to solve that problem is came up with integration platforms, integration tools. You would have middleware as a whole topic of conversation, really, and a whole, kind of SKU unit of tool sets from the vendors. And they were needed. It helped you get all of the disciplines for talking from system 1 to system 2. Gave you mapping tools, gave you error handling, error hospital tools, gave you transaction management and orchestration over it, gave you the monitoring tools, all very good and popular. A lot of large companies, integration companies, were acquired by the large vendors, by IBM, Oracle, SAP, so the likes of MuleSoft, the likes of BEA, who had integration service buses, were all kind of acquired by the large apps vendors to make it easier for you to integrate between 2 systems. Now, what tended to happen in the market is people not only use those integration platforms for integrating between very well-defined SaaS applications or on-premise enterprise applications, but they used it for their custom systems as well. So people wrote services, web services originally, API kind of implementations of those more latterly, that use those integration platforms features to allow you to talk between your custom systems as well. And what tended to happen in my experience when I went in and reviewed these with clients is business logic bled into those systems. When there was a misalignment between system A and system B, and one treated the business object in one way and another in a slightly different way, that was built into the integration platform, and it became the most critical element, the central nervous systems of people's applications. And not only it became the central nervous system for the integration touch points of making sure everything was monitored and worked smoothly, but for business logic as well, for orchestration of multiple steps to the system, for error handling strategies from the business, that if that order isn't created when we want to create a shipping, what do we do? And became hugely complex. So then grew beyond kind of an integration platform and more part of that solution. And I've seen a lot of sort of failures of solutions, not because of system A and system B, but because the integration was failing between them. Seen a lot of integration platforms that have just stored so much data. There was a term called dehydration that I still probably, wake up with hot sweats from, where the idea of that is any state that is stored within the integration platform is written down to a database, allowing you to wake up again and continue where you were in that integration. So if something needed to do 3 steps and the second step was taking a long time, it would store all the metadata about that request and where it had got to. It would store it to the database so that if anything went down, whether system B went down or the integration went down or the network went down, it could recover and continue. Great in theory, great on practice, but when implementers wrote hundreds of these orchestrations, suddenly that was the bottleneck. Suddenly that database was the one causing the problem, which is crazy because the whole point of this integration was to ease your burden, right? So that's where we've got to, and I still see a lot of integration solutions that have these big integration platforms in place with a lot of logic in, a lot of orchestration, a lot of state management, and it's part of their challenge when they replace it, right? Now, there's a couple of things that we can do to make sure we're successful in that. The first is you've got to treat that part of the legacy. You can't say, oh, that's just the integration. So when I replace system B, I'm just going to look at system B as system A and get them to work. You've got to have skills to be able to analyze that integration platform as well. We can also learn from open source technologies. So open source has been a huge success over the last sort of 20 years at being able to change rapidly, being able to take in new advances and innovations from the public, from industry, from people who are working across different projects, and be able to update their systems and be able to say, well, there's the code. You take that code when you're ready to take it. You take the version that's appropriate for you at this moment in time. So not tying you to platforms and products, but giving you tool sets to be able to use yourself.
But of course, that's exactly what the vendor doesn't want, right? Because the vendor wants cold, hard cash, right?
Yeah, and indeed, absolutely. And what's ultimately to tie you to that product? They want business value, but it's great if you can take their big next upgrade and you can be a long-term customer for them.
Yeah.
So the question for me is, how can you take both? How can you take the investment that the vendors have done, but also the view that you don't want to be dependent on those platforms, that you want to be able to take your integrations and move it to other areas? And this is where actually the industry has gone down a good route with kind of API management tools, where they're saying instead of dealing with actually the service implementation and running that on our platform, you can run that service integration, service implementation for any integration or business logic on your chosen, cloud platform, your chosen Kubernetes implementation as an example. But what we'll do is we'll deal with the boundaries between two systems. So when you're calling an API, we'll make sure that's fully monitored. We're handling any errors, in calling that. We're making sure that is secured and you're allowed to call that. But we're not going to deal with any of the logic of how you're going to orchestrate, a number of calls together, or the workflow that you're going to kick off if there is an error that can't be handled automatically. So these integration layers have definitely thinned out to more policy-based integrations where you can apply policies across it. And this means that, this kind of the mapping of the APIs from one system to another, will have some business logic in. How do you want to use that dependent system? And it's more now like the patterns of dragging in an open source library to create a PDF, let's say from JavaScript, where you're saying, how do I want to use that API that I'm dependent on? what do I want to put as the input? What's my success criteria and my acceptance criteria for calling that? And you can treat that now as, rather than just an external dependency that you're trying to integrate to, as a first-class citizen almost in your product, although it's been implemented by someone else.
Yeah.
And you can start saying, right, what do I need out of that? What will the test look like? You know, we do quite a bit. We've been looking into contract-based testing, for instance, which is sort of trying to share with your partners how you're going to use their dependent API and creating with them a test that can be run so they're not breaking your code. You know, so really treating these dependencies as first-class citizens in the new system. And I think that's one of the key success factors of suddenly not being dependent on a large integration platform, taking that into your own ownership of that.
Not all integrations are the same, right? So some we're dependent on and others we're pushing out. Talk us through how it's not just one size fits all.
Yeah, it's a really good point actually, Reuben. In this, you know, there will be certain systems you're dependent on, and they'll be written in different technologies. And this is where integration platforms really help. They help to create adapters that would allow those to, you know, be treated the same. And you still want that same approach for the dependent systems. You want to write something that exposes the functionality in that in a way that you can easily consume via API, so that still fits. But even more important, you need to make sure your system, as you change it, is still giving what other systems who are using your functionality need, right? There's a great sort of law called Postel's law that's been used in a lot of design patterns. I know, for instance, Martin Fowler referenced it in, you know, over 10 years ago in his integration design patterns book, about being conservative in what you do, but be liberal in what you accept from others. So be very careful on the APIs and the dependent services you use. Make sure that you are monitoring it, expecting errors in that, you know, dealing with failures in those. But for when you're accepting requests from others, be tolerant of what they're doing. You know, make sure you've got backward compatibility. Make sure that when you roll out a new version, you can allow those consumers to move at their own pace. So when you're designing a new system and migrating your legacy or transforming your legacy from it, you really need to put the effort into thinking about how those APIs will work that allow your consumers, you know, to accept it, to use those systems in the way that they want to use them. So, you know, really a legacy system cannot be transformed until everyone who is using it or integrating to it gets what they need out of that integration. And we have a lot of discussions and put a lot of effort into design of how things should be, where things should be backwardly compatible, where actually it doesn't make sense. And we want the consumers to move to new versions, and how normally where we do a middle ground of a staging between those. So really important to think in that way, I think.